All right, so it says a ball A has a mass of 9 kilograms. Ball B has twice the mass. What's twice of 9? 18 kilograms. The two balls collide and stick together in a perfectly inelastic collision. After the collision, the combined balls are at rest. Ooh, that means that V final equals 0. If the initial velocity of A before the collision was this, what is the initial velocity of B? So we need V initial of B. This is V initial of A. So it's still a conservation of momentum, right? So I'm going to have the mass of A times V initial of A plus the mass of B times V initial of B. Because it's an inelastic collision, I'm going to have the mass of A plus the mass of B times the final velocity. All right, so here's an interesting thing. This becomes 9 plus 18 times 0. So this whole thing is going to go away to 0. Now over here on the left-hand side, I've got 9 times 15 plus 18 times this. That's what I got to solve for. Okay? So this equals 0. 9 times 15 is 45 plus 90. Is that 135? Somebody double check that. It's amazing, isn't it? So now I'm gonna, that's what I do. So I'm just doing algebra. Remember, I got to solve for V initial B. So I'm going to just start moving things away. I want to make it look like V initial B equals some stuff. Okay. So using algebra, I subtract 135 from both sides. That gives me 18 VIB is equal to negative 135. Divide both sides by 18. The 18s will cancel, and I get VIB is equal to, is that about, is it 7.5? What is that? Yeah, I forgot about the negative, but yeah, negative 7.5 roughly meters per second. And the negative is important. It just means it's going in the negative direction. So don't forget that, like I just did when I said it. Okay. Any questions on this one?